Hello everyone, we're going to performing operation functions, or we're going to do operation with functions. For this lesson, the objectives are: I can explain what it means to perform an arithmetic operation on two functions. I can find arithmetic combinations of two functions. I can state the domain of an arithmetic combination of two functions, and I can evaluate an arithmetic combination of two functions for a given input. So we're going to explore all these topics. For example, in part A, we're going to have describe what it means to add two functions, then describe what it means to subtract one function from another function. This one, it seems to be something complicated, but basically what it is to add, to form a new equation. Okay, what it means to add two functions is to add to form a new equation, and subtract to form a new equation. Okay, that's adding and subtracting. You're going to form a new function or a new equation, and so on. Now, on the second one, match each function with its graph. Explain your reasoning. Remember that we're going to use this function. We're going to use this y equals fx. Now I can see that this function goes through 0, 0. So this one goes through 0, 0, and this one is fx, the function fx. So what that means? What it means is that f of 0 is equals to 0. And the second function, I can see it's pretty obvious that this line goes through 0 and -1. So the second one goes through 0, -1. So my gx function, in this case, is going to be g of 0 is equals to -1. That's fx, that's gx. Now what we're going to do, we're going to perform these operations. So in this case, let's do A. A is mx. You're going to create a new function, mx, okay, that is equals to fx plus gx. Remember that in this case, fx, I'm going to have f of 0 because that's the information given to us, plus gx, or g of 0, okay? So what is this one? I know f of 0 is 0, and then I have that g of 0 is -1. So 0 plus -1 equals to -1. Now, which function gives me -1? So in this case, we're going to have, let's say, this is 1, this is 0, this is -1 here. This is -1, so it's C. This one is the letter C. Now let's do the second one. Let's do B. And this, I'm going to call this one B, C, and D. So let's do B. I'm going to use this different color. So I'm going to have nx equals to fx. But so I'm going to do is f of 0 minus g of 0, which is equals to f of 0 is 0 minus -1 equals to +1. So which function in this case is +1? I have A. Okay, that's my new, that's A. We're matching. Let's do C. I'm going to use the red again. C. So I have px equals 2, and then I have, it's a multiplication, fx, so f of 0 times g of 0. So this is equals to, I know fx, f of 0 is 0, times -1, and this is equals to 0. So which function is this one? So this one is going to be B. And this, wait, give me one. This one is either B or is either D. So we are going to identify which of these two functions is going to be. So in this case, observe this one. Remember that this fx is the parabola, right? Is the parabola. So I have x squared, And then I have this function here, which is the line function, the linear function, that is x, and this one is x to the third power. So it goes through 0. So in this case, C is going to be letter D, because it's the cube function for that one. I know now by elimination that the last one, number 4, is going to be, in this case, B. Okay, can we give it a try? Yes, we can give it a try. So we have, I'm going to call this one D, and I have QX equals to fx, or f of 0, divided by g of 0. So this is equals to have 0 over -1, which is equals to 0. And as you can see, it goes to 0. That's the last one. But we can do, remember, you have x squared over x, which is equals to x if we simplify. So for D, or number 4 option, is B, the graph of B. So let's move to C. What is the domain of each function in part B? So we're going to find the domain. So in this case, for the part I, double I, or 2, and 3, okay, we're going to have that the domain is all real numbers. For the domain is all real numbers, okay? And what is the domain in this case for the QX, okay, for 4, or QX in this case is going to be, domain is all real numbers except what is in the denominator, okay, except what is in the denominator. Remember, it's a division, and except what makes denominator 0. Okay, that's your constraint on that function. Now on D, they're asking, check your answer in part B by writing function rules f and g, performing each arithmetic combination, and graphing the results. Now what we did here was a rough draft of the graph, like the parent function, so we can get that information. But if we use the knowledge that we have from the previous classes, remember that this one is going to be, if we do the table of value, I'm going to have that fx, I'm going to write it here, fx is equals to x squared minus x, and gx is going to be x minus 1. So those are the actual function. If we do the table of value, see this function went down 1 unit. This one moves here at the center. So if we do the table of value, we're going to get these two functions. So now I'm going to do mx. So I have m of x, remember, is equals to fx plus gx. So this is equals to x squared minus x plus gx, which is x minus 1. What is that one equals to? X squared doesn't have a like term, so it's just x squared. Then I have negative x plus x is 0. And then I have left negative 1. So x squared minus 1. And that is the function that you have, x squared minus 1. So it went down 1 unit. So let's do now nx. Nx is equals to fx minus gx. So it's x squared minus x minus 1. So this is equals to x squared is still the same. And then I have negative x minus x is minus 2x. And then I have negative, and negative is positive 1. So in this case is our parabola that we have here. See? So that's the parabola if we graph those points. Then I have px equals to fx times gx. So it's equals to x squared minus x times x minus 1. If we apply distributive property x squared times x is x to the third power. Then if we simplify everything, I'm not going to do it step by step. 2x squared plus x. So that's going to be your function, which is option D. And last one, we have qx equals to, we have fx over gx, which is the division. So which is equals to x squared minus x over x minus 1. Okay, now we can simplify, we can factorize greatest common factor. We're going to have x is equals to x minus 1 over x minus 1. So it's equals to just x. So now we can answer this C part. We had the domain is all real number except what it makes the denominator 0. What is making the denominator 0? X minus 1. So I have x minus 1 equals to 0. So it's equals to 1. So the domain is all real numbers except negative and except positive 1. I'm going to have positive 1. So that's going to be the solution to the front page. So now we're going to move to the key ideas of this lesson. So remember that the key ideas in this case, let f and g be any two functions. A new function can be defined by performing any of the four basic operations. So we have addition, subtraction, multiplication. We also have division. Division in this case is the one that we need to be careful because we need to have a function that doesn't make the denominator equals to 0. It's not doesn't make. We need to have a function and then we need to state what values makes the denominator 0 so we can write the domain. So in this case, for example, example 1, I have let fx equals to square root of 3. Fx equals to 3 square root of x and gx equals to 3 minus 10 square root of x. Find f plus, I'm going to have plus g of x, right? And state the domain. Then you're going to evaluate f plus g of 4. So in this case, this is equals to, I'm going to have f of x plus g of x. And this is equals to fx is 3 square root of x plus 3 minus 10 square root of x. Actually, these two are like terms. So 3 minus 10 is equals to, in this case, negative 7. So this is equals to 3 minus 7 square root of x. Now what we are going to do, is evaluate the function. They're asking me to do f plus g of 4. Okay, I have my function here, 3 minus 7 square root of x. So I'm going to have 3 minus 7 square root of 4. I know square root of 4 is equals to 2. So I have 3 minus 7 times 2. I know now that negative 7 times 2 is equals to negative 14. 3 minus 14. And now 3 minus 14 is equals to negative 11. So that's the solution. Last one will be the domain. So the domain of the function is all real numbers. And because we have a radical, we're going to do x is greater than equals to 0 because I have the square root of x. So in this case here, the square root of x, x is greater than equals to 0. So the domain is all real numbers when x is greater than equals to 0. Okay, that reason why we put the x greater than equals to 0 because it's going to be all the positive numbers. We cannot have negative numbers, so I should be more specific with this one. So the domain is I'm going to have all positive real numbers, just leaving x greater than equals to 0. Okay, example number 2, or B in this case. So I have fx equals to 5 square root of x and gx equals to negative 8 square root of x. Find f plus gx. So we are adding right now. So I have f plus gx equals to fx plus gx. So what we have, I have 5 square root of x plus negative a square root of x. Now positive and negative is negative, so I have 5 minus 8 square root of x, and 5 minus a is negative 3 square root of x. That's your function. Now they're asking me to do f plus g of 16. So I'm going to have f plus g of 16. So this is equals to negative 3 square root of 16. I know that in this case, square root of 16 is 4. So it's equals to negative 3 times 4. And it's equals to negative 12. Okay, that's the evaluation. Remember, in this case, I have negative 3 square root of x. So my domain is going to be x greater than equals to 0. That's going to be my domain for this example. Now let's move to example number 2. In this case, for problem A, okay, example 2a, we're going to have fx, I have the function, I have gx, and I'm going to do the subtraction. So I'm going to have f minus g of x, which is equals to fx minus gx. So this is equals to 3x to the third power minus 2x squared plus 5 minus x cubed minus 3x squared plus 4x minus 2. Now, what is going to happen? This negative is going to change the signs of the second parenthesis. So, for example, this is going to be equals to 3x cubed minus 2x squared plus 5. And I'm going to switch this negative for a positive. And now we're going to have negative x cubed plus 3x squared minus 4x plus 2. See, I just switched the signs, and now I'm going to perform this operation. So I have 3 plus negative 1, because these two are like terms. So I'm going to have 2x cubed. 2x cubed. I do have another 2x squared, 3x squared. So I have negative 2 plus 3 is equals to x squared plus x squared. I don't have an x element here, so I'm just going to leave it minus 4x plus 7. Okay, because 5 plus 2 is 7. And now I'm going to do f minus g of negative 2. Negative 2. So we are going to have 2 negative 2 to the third power plus negative 2 to the second power minus 4 times negative 2 plus 7. And if we put this one in the calculator, we're going to have that this is equals to 3. Okay, to 3. Now let's do B. For B, we have the same. F minus G. So I have F minus G of X, which is equals to F of X minus G of X. So it's equals to 2x cubed plus 4x squared minus 8x plus 4 minus 3x cubed minus 5x squared plus 6x minus 9. Now we're going to perform the operation. I don't need to do this sign change. I can just do 2 minus 3 is equals to negative x cubed. Now for x squared, do I have another one? Yes, negative and negative is positive. 4 plus 5 is plus 9x squared. Now 8x, negative 8 minus 6. So it's an addition of two negative numbers is equals to negative 14x, and 4 minus negative 9. So I'm doing double negative. Negative and negative positive. 4 plus 9, which is equals to positive 13. Now I'm going to do f minus g of negative 1, which is equals to negative 1 to the third power plus 9 times negative 1 to the second power minus 14 times negative 1 plus 13. Plugging that one in the calculator, so I get 37. Okay, Number 3, we're going to multiply. We're going to multiply. Let fx equals to x squared and gx equals to the square root of x. Find a if f times g of x. And state the domain. Then evaluate f times g of 9. So what we're going to do here is I'm going to write fg of x, which is f of x times gx, which is x squared times the square root of x. Now let's go back to the properties of exponents. So I have x squared times x to the 1/2. Same base, we add the exponents. So we have 2 plus 1/2 is 5/2. So I have x 5 over 2. That's my solution. Now I'm going to do here fg of 9, which is equals to 9 to the 5 over 2. That's 9 to the 5th power, and then you can apply the square root, and this one is going to be equals to 243. 243 is going to be the solution. Let's do B. B, in this case, we're going to have f times g of x. So I have a bigger polynomial, fx times gx, which is equals to x squared minus 4 times 2x cubed minus 3x squared plus x minus 5. This one, basically what we're going to do is apply the distributive property. Okay, so x squared times 2x cubed, yada yada yada. So what we are going to have, let me write these ones here. I'm going to have 2x to the 5th power, x squared times 2x cubed, 2x to the 5th power. X squared times negative 3 is negative 3x to the 4th. X squared times x is plus x to the 3rd. X squared minus 5 is negative 5x squared. Now I move to the negative 4. Negative 4 times 2 is negative 8x to the 3rd power. Negative 4 times 3 is equals to positive 12x squared. Negative 4 times 1 is negative 4x. And then I have negative 4 times negative 5 is positive 20. Let's combine like terms. So this is equals to 2x to the 5th power. And then we are going to have minus 3x4. Then I have x cubed minus 8x cubed. So it's minus 7x to the 3rd power. I have x squared, negative 5 plus 12. In this case is 7x to the 2nd power minus 4x plus 20. Now what I'm going to do is evaluate the negative 1. So I'm going to have f times g of negative 1. So it's equals to 2 times negative 1 to the 5th power minus 3, negative 1 to the 4th power minus 7, negative 1 to the 3rd power plus 7, negative 1 squared minus 4, negative 1 plus 20. And if we plug in the calculator, we're going to get 33. Okay, that's example 3. Let's move on to example 4. Example 4 is going to be the division of those functions. So now we need to be careful with the denominator. So I have fx is equals to 6x, gx is equals to 3x 3 to the 4th. So I'm going to do f over g. Okay, so what we're going to have is f over g of x is equals to fx over gx. So what we have, this is equals to 6x over x to the 3/4. Properties of exponents. So what we're going to have here now is equals to 6x 1 minus 3/4. We'll perform the operation, and this is equals to 6x to the 1/4. So we don't have anything in the denominator, but still, look at this one. I have x to the 3/4 here. So I need to put that the domain of this function is x greater than equals to 0, because it's a radical function. I have 1/4 with the denominator 4 is an even, so x is greater than or equals to 0. Now I need to do the evaluation. So what is 6 times 16 to the 1/4? That one, if we plug it in the calculator again, this is the 4th root of 16, which is 2. 2 times 6 is 12. So I have 12. I left the spaces too small, so need to make it. So now I have fx over gx. So I have fx over gx. So this is going to be equals to x squared minus 16 over x squared minus or plus x minus 12 here. So we need to factorize. So we are going to have x squared minus 16 is a difference of squares. So this one is going to be x plus 4, x minus 4 over x squared plus x minus 12. So I have negative 12. I need two numbers that multiply each other will give me negative 12. So in this case, I'm going to have 4 and 3, x plus 4, x minus 3. These two cancels out. So what I'm going to have left here is x minus 4 over x minus 3. What is the domain? We're going to evaluate later. So what is the domain? So the domain in this case is going to be all the values. The domain is going to be all real numbers except 4. X is going to be different than 4. Okay, for this problem. Now we're going to evaluate. Remember, we're going to do 2. So this is equals to 2 minus 4 over 2 minus 3 equals to 2. So that's going to be my solution for that B. Let's do C now. So in this case for C, we're going to have the same. So I'm going to have f over g of x is equals to fx over gx equals 2. And I have x plus 6 over 2x. There is nothing to simplify there. There is nothing to simplify here. So I'm going to have the domain is going to be all real numbers except x equals to 0. Okay, 0 cannot be in the denominator because it will make it 0. So we're going to check B again because the domain here I have x plus 4. So the domain is going to be all real number except negative 4. I was just looking right now that x minus 4, negative 4 plus 4 is 0, but also x cannot be positive 3. X cannot be positive 3. Last example that we have there is an application that we have. We have that for a rhino heart rate in beats per minute, a lifespan in minutes are related to body mass m in kilograms by the following function. So we have the heart rate is r of m equals to 241 m to the negative 0.25. Lifespan s of m is equals to 6 times 10 to the 6 m to the 0.2. Find rs of m and explain what represent r times s. So I'm going to have r times s of m is the same as having in this case r of m times s of m. So it's equals to 241 m to the negative 0.25 times, I'm going to open this bracket, 6 times 10 to the 6 m to the 0.2. Okay, if we perform the operation, we're going to multiply 241 times 6 times 10 to the 6. We're going to use the calculator, the graphing calculator if you want, or a normal calculator, but we're going to get 241 times 6 times 10 to 10 to the 6, and then we're going to have m. Remember, the bases are the same, and then we're going to add negative 0.25 plus 0.2. And what is 241 times 6 times 10 to the 6 is equals to 1,446 times 10 to the 6 power m to the negative 0.05 if you use the calculator. Now, if we move this decimal point to 1.4 times 10, this one is going to change. 1.446 times 10, we move 1 to 3 units, so we're going to add 3 units to the 9, m to the negative 0.05. And in this case, that is going to be the solution to this problem that we have. So in this case, if you have any question, just let me know so we can discuss.